Welcome to lesson 26. We're talking about functions. Here's our criteria for success. We want to be able to accurately and consistently determine whether or not a relation is a function. So that's number one. And this can either be when you're given ordered pairs, a table, or a mapping diagram to be able to look at it and identify it. That's a function or no, it's not. And then justify a relation as a function. So at times, can you explain how you know it is or is not a function? And finally, if they give you a graph, could you use the vertical line test to determine whether or not it's a function? So let's go back and think about when you were younger and you would get these in and out tables and a number would go in, something magical would happen, even though we know it's not magic, some type of rule, and another number would come out. So for example, let's say it was times 3 and you put a number in, like you put 3 in and a 9 pops out. You put 12 in and a 36 pops out. So we've been getting, since a very, very young age, we started talking about thinking about the idea of a function. And now that we're in Algebra I, we can define it as the relationship between a set of inputs where each input has only one output. There is some type of relation happening here. So when something goes in, we can determine exactly what's going to come out. But the idea that there is only one input for one output. You're going to see tons of equations, and at times we're going to have to rewrite them as a function or vice versa. So here's the skinny on function notation. It pretty much means not every equation will have two variables in a function. So sometimes we'll use a function notation where we say f of x. That's how we'll say it. And we're just replacing the y with an x. So here's our first example. I'm just going to go into it over here. If y equals 5x plus 3, I can rewrite this as f of x is equal to 5x plus 3. And the same can be true on the bottom. If f of x is equal to 6x minus 9, I can rewrite this as y is equal to 6x minus 9. So let's talk about how to recognize it, and we're going to look at two examples. If you have coordinate pairs or with mappings. Again, remember our big idea, each input only has one output. So when you're looking at the pairs, this one over here is a function because each one only gives one answer based on what we have. But in our second one, here's our red flag, where we have 5 is our input, but I get an A one time and a C another time. So that is why it cannot be a function, because we can't have two different y values. So if you see that, that's your sign that it is not a function. All right, so if a number goes in for x and you get two different answers for y, it's not a function. And that's also true with mapping. Look at 5. I put in 5 and I get two different answers. So this shows me x has two outputs. So this is why it's not a function. Every number should only have one output, and that's what you're seeing on the other side. Everyone has only one output. This is okay, where I put in a 1 and I get B, and I put in 8 and I get B. That is okay. That's still one output. But I can't put in one number and get two different answers. So let's look at this first example here. Do you recognize, look and see which one is not a function? Which one does not have one input for one output? Take a moment. All right, and let's do the reveal. It would be C, because here 5 has two outputs. I have a 4 as an output and I have a 6 as an output. If you had chosen 1, remember this is okay because each of these has only one output. Same thing with 4. Each of these has only one output. But if one of these numbers went to two different numbers, then it would not be a function. Let's look at our second example. Is this relation a function, and explain? So remember, you're scanning and you're looking to see one input. One input. And it's hard because when your eye goes fast, you might see a 3, a 3, a 3 and get confused and wonder, does that mean I have more than one input? So if you get stuck like that, you can just map it yourself. And -1, 3. 5, 3. 2, 3. -3, 2. So this does show me there is only one input for one output. So yes, this is a function. There's one input for each output. So this part would be okay. Now the other way I can look at this is I can actually graph it. And what you're looking for in the graph is that none of them are stacked on top of each other. And you can see here all our points are in different places. They have different x values. So it doesn't matter that these three are in the same line horizontally. As long as they are not stacked on top of each other, this is a function. And now we're up to our last example, graphs. How can we look at a graph and tell whether or not it's a function? So what I will tell you is that if you see them stacked on top of each other vertically, it is not a function. So that's what you're looking for. And the way we test this is with what's called the vertical line test. In other words, you draw straight lines going down, and if you hit more than one place on the graph, it's not a function. That's it. It can only touch one time. As long as it touches one time, it's a function. If it touches more than once, not a function. So, and the first one is really easy to spot. Here's a straight line, and you can see it touches in 3 different places. It touches here, here, and here. So, not a function. But on this one on the bottom, I can draw a bunch of straight lines, and it's still only going to touch it once. So that's what makes it a function. And that's what I was talking about in the last problem. I can draw a straight line through any of these points, and they don't stack on top of each other. And that is why this would pass our vertical line test. And you can literally annotate VLT for vertical line test. So let's go to our last example, which graph does not represent a function. Hit pause and just mentally draw a line straight down which one touches more than once. Okay, if you got 4, then you would be correct. In 4, I can draw a straight line, and it can touch in more than one place. So just because it touches twice, not a function. And we will put vertical line test fail. All right, so that's it for this lesson, Math Marvels. We're gonna get some practice. This is a really visual lesson. You're gonna have to just look to recognize if something is a function or not a function using on a graph or on mapping or with coordinate pairs. So look carefully, take your time, and ask questions when you get stuck. I'll see you in the next lesson, Math Marvels. Be well.